So you notice that the IP addresses are denoted by numbers, and that could be just any number as long as it is less than 255.
250.
Right? We'll know why in a minute. IP addresses are divided into classes because there's a whole range, from 0 all the way up to 255. 10 or somewhere in the middle, 172 is in the middle, 192 in the middle, right? And hence, there's an organization called as IEEE that said, hey, let's go ahead and split this large, voluminous range into smaller chunks. And let's call them as classes, which is class A, B, and C. Okay? And then a request for proposal, which is called as RFC. Yeah? RFCs were sent out, and they said that we're going to have different classes of IP addresses. And that RFC was called as RFC 1918. It's a document. According to RFC 1918, IP addresses are classified as class A, B, C, and D and E as well. But we do not use D and E in our regular lives. They are only used for research purposes and educational purposes. We do not use them. What is class A? So when you do IP config on your computer, heard of this command?
Yeah.
Right? When you do IP config on your computer and you see an IP address that starts with 10, that's a class A. 172, that's a class B. 192, that's a class C. All right. 192.168. something is a class, let's say x.x. 172.30. something is a class B. Anything that starts with 10.x.y.z is class A. Simple? Apart from that, there is a special IP address, 127.x.y.z. This IP address is called as a loopback address. Called as what? Loop back. And if I have to just convert this string, loop back, into a picture, I'll say loop back. Right? Looping back.
Loop back, okay.
Looping back. Looping back to what? So this is primarily used for testing purposes, testing your network card. You are aware by this time that every piece of hardware on your computer needs a driver. Hardware needs a driver for us to talk to the driver, and driver then communicates and sends the calls and signals to the hardware. And if you want to know if that network card is functioning properly or not, you do a loopback. There's a command called as ping. Ping. P-I-N-G. There was a girl in my class, and she was so happy. Is it pink?
Yeah.
We were like, is it pink? I was like, is she intentionally saying that? She was not aware. So I said, no, lady, it's not pink. It is pink. This happened. she was not aware, right? So ping is an acronym that stands for Packet Internet Gopher. So now if you put a magnifying glass on ping, this was a term that was coined by the DoD guys, the USMC, Marine Corps guys. And they had a ship that was going from point A to point B. It was going all along the ocean, and they need to find out what the depth of the ocean is so they can find, or they can stop the boat right before they hit some kind of a rock or something, right? So if the rock is here and the ocean waves are here, the boat will of course go and hit the rock. So they need to find out the depth of the ocean so they can stop, be proactive and take precautions, so they can save the boat. So they said, okay, let's put a device right here, and that will send ultrasonic waves all the way to the bottom of the seabed as light comes back up. And then now we know that the speed of the light, which is a constant, right? We also know, we can find out the speed of the light is, that is speed. And we can figure out the distance because they can calculate the time. They can calculate the time it took from point A to point B. Speed is equal to distance by time, so it's very easy to calculate the distance. So if the distance is very small, they put the brakes and stop it. And they said, hey, let's ping it, right? So ping is a term that is coined by these guys, and now we are using in IT, and we created a tool called as ping.exe, which is used in Windows, Linux, and all flavors of operating systems today. So ping is used to do what? Ping is used to find the distance between point A and point B. So let's say this is your computer, right? This is your computer A, and this is your computer B. Computer A is here in New Jersey, and this guy is here somewhere sitting in Toronto, in Canada, and you want to ping from here to here. Remember that when you do a ping, it must also reply. And this will reply because it's a computer, it's not a seabed, right? In seabed, it's going to reply anyways because seabed exists everywhere. But here, this computer may be shut down, it's not alive, probably it's dead, or is on. If it is dead, of course, it's not going to reply. If it is on, that's when it will reply. So machine A tries to ping machine B, it's going to respond back, and then it will tell you that the distance is probably not in miles, not in nautical miles, but here the distance is in milliseconds. Let me just quickly show that to you. So I've launched the command prompt here. So I've launched command prompt, and if you do ping, that is ping, okay? And then I say www.yahoo.com. I'm not connected to the internet, by the way. That's why it says request timeout. But if you do ping, you will see the time here in milliseconds. Yeah, give it a shot. Make your notes and
Commands dot ping.
Ping space, and then any remote machine. I'm using yahoo.com here.
Okay.
Ping space, yahoo.com, google.com, facebook.com, or anything. So what you will research on is the classes of IP addresses, classes of IP addresses, and more about ping and more about IP config. Right? Every command has syntax. Every command has a syntax, a lot of syntax. So you can find out what the syntaxes in ping are by doing /?, ipconfig /?. Right? And those syntaxes will help you learn more about each of these commands. Learning these commands is a journey, so you have to experience those commands. You need to know what it is doing because they will help you troubleshoot things.
Yeah, you gave me the whole list of it, right? You gave me the whole list of like what is the like CLS means and
CLS, yeah.
Yeah.
Those are DOS
Yeah,
commands.
yeah.
DOS commands. So you know about the classes of IP addresses, class A, B, C, right? All right. The question of why I cannot have more than 255 range, right? Your computers do not understand numbers like this: 1, 9, 2s, 1, 6, 8s, 10s, and 172s. This is only for our representation. So we can look at it and understand the nomenclature. But computers don't like it. Computers don't understand this terminology at all. They will definitely convert it into something that they understand and then interpret it moving forward, right? In the network transmission. But these numbers are numbers, and alphabets and commands are only for us, for human beings. Computers convert it into something else. So these are called as decimals or binaries. These are decimals, or these are definitely decimals, right? They are called as decimals. So you can convert this decimal to binary. What's your education like? Is it into engineering or MBA?
I did home science, if you ever heard about it.
Home sciences?
Yeah.
No.
No.
Yeah. What's that?
It's like everything.
I know science. I know home separately.
Yeah, but it's combined. Like, so you learn everything about the home science, like for the. I don't know.
What are the subjects in it?
There are so many like general subject, and child development and food
Psychology?
And, and then.
Okay.
So many things like, but it's not like that's why I didn't like myself like mathematics, so I didn't go in a commerce like thing.
Okay.
So,
Okay. So these are decimals, and computers convert them to binary.
mhm.
So we'll understand how they actually do that, and it is simple. And you love mathematics from now.
Yeah, I have realized that
Because you have done
yeah.
it like several times in your life. Division
Yeah.
by 2.
Oh yeah,
right?
yeah,
Maybe your kid does that. My kid does that too. So
Mhm.
she does this 192, and I say, hey, can you divide this by 2? She
Yeah.
puts 2 right there, and starts using the multiplication table that they learn. So 2 nines, what, 18, and then we have one remainder.
Mhm.
I will put it here, and so I've got 12. So balance is 96. So
Mhm.
when I divide 192 by 2, what do I get? 96. Is there a remainder? The remainder is 0, isn't it?
0, yeah.
Nothing. Right? So I'll still put it there because
Mhm.
0 has value. I'll put it there. And then divide this by 2 again till the time I'm done. 2 4 is 8, 2 8 16, remainder 0. Am I right?
Yeah.
Then do it again. 2 24, remainder 0 again. Yeah. 2 12. Am I doing it right?
Yeah.
0 again.
Mhm.
Then 2 6 12.
6.
Remainder 0 again.
Mhm.
2 3 6.
3.
Remainder 0. 2 1s. And then remainder is 1.
1. Mhm.
Perfect?
Yeah.
Yeah. Maths is easy, right? So we'll write this binary notation
Binary.
in a reverse way,
Mhm.
right? And we'll call it as 1 1 0 0 0 0. Is that? Yeah.
Mhm.
Simple?
Yeah.
So 192 in decimals is 192, but in binary it is
1
this.
1. Yeah.
You must also know how to do the reverse way. How do you convert binary to decimal? And that is easy as well. Easy as well when I say that. Let's show how. I'm going to put numbers like this. Yeah? Just 0 all the way through 7. Anything that has a 0, I will just negate it. I will not care about them.
Mhm.
The ones that have 1 is something that I will care about. Here, when you want to convert decimal to binary, you divide it,
Yeah.
the number. Here, I'm going to do 2 to the power of that number
7. Yeah.
plus 2 to the power of that number.
Mhm.
I could have done again 2 to the power of 0 and all that, but I will not do because 0 is there, which we don't care. So what is 2 to the power of 7? Whatever, 2 to the power of 6, whatever, but if you add them, it will be 192. Right? That's simple as well.
Mhm.
Okay. So we got 192 as 1 1 and couple of zeros. How do I remember how many zeros? Because after converting, I'll always get 8 placeholders, and those placeholders I'm going to call them as bits. So how many bits do I have? 8 bits. 1 2 3 4 5 6 7 8. It's always going to be 8 bits.
bits, right?
Always
Yeah.
8 bits. Let's do the same thing for our next friend, 168. Okay, 168. 2 8 16 4, remainder 0. 2 4s 0. 2 21s 0. 2 10s 1. 2 5s 0. 2 2s 4. 1. 2 1s 0. Right. So now we got 1 0 1 0 1 0 0 0. Right. 1 0 1 0 1 0 0 0. How many bits do I have now?
8.
It's always going to be 8. If it is not 8, you make it 8. When I say we make it 8, this is how we're going to make it. So 10, 2 5s, 0, 2 2s, 1, 2 1s, 0. I'm done. I'm not getting 8 bits here. What do I do? Well, I will say 0 0 0 0 and then 1 0 1 0. Yeah. Done?
Yeah.
And then the same thing for that guy, 172. Do you want to try for 172? What is, well, let's put a simple number there, maybe 30. Do you want to try converting the decimal 30 to binary? Go ahead. What'd you get?
I get like 5 bits. So I can add 0, 0, okay, 0, 0, 0, 0, 1, 1, 0. 1, 2, 3, 4, 5, 6, 2, 7. 5 zeros, 1, 1, 0, I think.
5 zeros? Yeah. So, how did you get 5 zeros?
I don't know, did I get, so, 30?
2 15s,
So
perfect,
15
0,
zero.
okay.
7.
7s, 1, okay, 6, 1, okay. 2 1s, right? 2 2s is 4. 2 1s.
Mm-hmm.
Here, yeah, the last 2, replace that with a 1.
1, yeah, and then,
No.
You're keeping the
Here?
reminder value.
This is 2 1s,
oh yeah,
isn't it? 2 1s, 2 1s, 2, and the remainder is 0.
remainder is 0. Okay. Okay.
So you got 4 1s.
4, yeah.
1, 2,
1, 2, 3, 4. Yeah.
the 3 zeros
Mm-hmm.
in front of it. Yeah, perfect. And then the last one is 0.
Last one is 0. Yep.
So how many bits do we have?
8 now. Yep.
Yeah. So you can also convert it the other way where you do binary to decimal conversion.
Mm-hmm.
Yeah?
Yeah.
You've done IP config before, right?
Yeah.
What do you get? A lot of things.
Lot of things,
Not
yeah.
just IP address.
Yeah.
You get like IP address, you get subnet mask, you get default gateway, preferred DNS, alternate DNS, preferred wins, alternate wins, a lot of them.
Mm.
They are called as TCP IP properties.
Yeah.
TCP IP properties. So how do we get TCP IP properties? By doing IP config.
IP config.
And every property, every attribute has certain meaning. It has a meaning, right? And it exists for some reason. Now we need to know what is the reason. These are real fundamentals that will help us troubleshoot complex situations. If the fundamentals are not right, we'll be stuck for days and days and hours. Yeah? And consultants make a lot of money just because they know the fundamentals. There was a story of an old man, right? Old man going and hitting the big shipyard, big ship, because that's stuck in the middle of the ocean for months and months, and this old man comes and fixes that in just an hour. And he charges them a whole lot of money. He just knows where to go and hit that hammer, that's all. It's all about getting those fundamentals right and knowing each of those properties of the TCP/IP properties. So the first one is an IP address, which we haven't covered completely yet, not even, I'll say 10%. But still moving on to the second section, which is subnet mask. So when I do IP config, you get IP address, and the second one is subnet mask. What is subnet? So if I split up these two words, subnet, it's again an acronym. Net is for networks. Sub is like a part of it, right? Subset of it, right? A part of the network is subnet. All right. So that means that the networks are primarily defined by the subnet mask, which will usually appear something like this: 255.255.254 or 255.0. They look like that. If I do IP config, that's what you will see. There's an importance, there's a meaning to that, and we'll understand the meaning in next 10 minutes. But before we do that, we will convert this decimal value to binary again. If we do this conversion for 255, it is 1111111. 255 is all ones.
Oh yeah.
If we do that, 255 is all ones. If we start dividing by 2, 55, 2 ones, 2 twos, 2 fours, balance 1. No, 2 sevens. 2 ones, 2 twos of 4, 1, 2 sevens, yeah? 2 6, 3, balance 1. 2 3 6, 2 ones, again 1. 2 15s, balance 1. 2 sevens, balance 1. 2 threes, 1. 2 ones, 1. See, it's all ones. So let's finish this. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And the last one is 0. 0 is always all zeros. Okay? Good. So, in electronics, there are chipsets. So when you open up your computer, this device, the mobile phone, you will see a green colored printed circuit board called as a PCB. And that has a lot of chips inside it, the black color, which looks like a centipede, which has a lot of legs, right? So that chip again has something called as registers and flip-flops, semiconductors and gates. So we're just putting a magnifying glass on the chip, right? If you open it up, do a postmortem of the chip, you will see smaller devices. And the smallest device that we can talk about is something called as a gate. This is called as, this kind of a gate is called as AND gate. It is not required for your certification. It's not even required for any troubleshooting, just for the knowledge. This is called as AND gate. And there are other kinds of gates as well, OR gates, NOR gates, XOR gates, NAND gates, but just park it for later discussion. At this time, we'll just focus on AND gates. What does it do? It does multiplication again. The names are complex in nature, but if we give input to this as 0 and 0, the output is 0, multiplication. Does that make sense?
Mm-hmm.
And if I give input as 0 and 1, again 0, because it's multiplication.
Mm-hmm.
1 and 1, it is 1. 1 and 0 is 0. Multiplication, right? Simple. Why are we talking about this? The network card does this calculation. The network card, which is attached to all of these devices, does that calculation. So let's do it for IP address and subnet mask. 1 and 1, multiplication. 1, 1, 0, 0, 0, 0, 0, 0. Correct? This is 1, 0, 1, 0, 1, 0, 0, 0, 4, 1, 0, 1, 0. And zeros multiplied by anything is a big 0, so I'll be lazy and will not write 8 times, instead write once. Got it? Done?
Mm-hmm.
Okay. So we have a device called A, who has an IP address of 192.168.10.30. When we do IP config, we also get the subnet mask as this. Good. And that device is that laptop, let's say. And I have another device which is sitting on the bed, and I'll call it as B. And because these two devices cannot have the same IP address, I will call its IP address as 192.168.10.40. Does that make sense? Okay.
Mm-hmm.
Just putting some random
IP
address. By the way, I've got how many bits in an IP address? 8, 8, 8, 8. Added on in all total, what is it?
32.
32. 8 4s 32. So I've got 32 bits in IPv4.
Mm-hmm.
And hence IPv4 is called as a 32-bit addressing scheme. There is another version of IP which is called as an IPv6, which is a 128-bit, which is massive in size. Why do we need them? Why do we need IPv6 when we have IPv4? Because when IP addresses were initially designed, the story of networks goes like this. We are deviating from this. We'll come back to this. There was something called as an ARPA network, ARPA network, that was initially created by the defense guys, DOD, for them to interchange information privately and securely between devices, right? Let's say there is a secret network somewhere here in North Virginia, and there's another secret network somewhere in California, and they want to interchange information. Today in this world, it's very easy to transmit information, but back in late 70s, it was difficult because nobody has laid underground cabling. It wasn't done. Underground as well as undersea cabling was not done at that time. It was later, with the advent of internet, that era gave the need for somebody to dig up the ground and put all the cabling done, right? But before that, Department of Defense had this technology to transmit using TCP over IP, right? So they were transmitting the data. But then they thought that why don't we just give it to outside people, because they had vendors. Vendors still had to send emails, not emails, but mails in the form of postal, which was using USPSC, but that was taking longer time. So they said, okay, let's give it to our vendors. So they started using, giving such kind of technology, which is specifically ARPA networks, using TCP over IP to the vendors as well. And for vendors to use it, they have to then come into a specific network to use ARPA network. They cannot just send an email from a Coffee Cafe Day or Dunkin' Donuts. They had to come into a specific network, which is the DoD vendors area, to send the network. It was again not that comfortable situation. So they communicated with the ISPs. At that point, Bell Communications was one of the leading ISP providers who was providing telephone lines to all SOHO customers. SOHO customers are small office, home office customers. So they said, hey, Bell Communications, come over here and distribute this TCP all over to the world. It was just overwhelming for Bell Communications because it's just too much for them. So they started bidding and got new vendors from different continents. BT, which is British Telecom, Vodafone, and various other companies came up together and said, okay, we will get interconnected. So that's when TCP/IP started flowing around, and in late 90s, it then arrived to almost all parts of the world. I'm saying almost all parts because even today, certain places in Africa do not have internet. Infrastructure is just too expensive out there, even today. Yeah. So that gave birth to IPv4, and all of our devices that we connect today have an IPv4. Public IP is not private IP addresses. But with the rise of population, you may say, or rise of devices, rise of IoT, Internet of Things, you need a lot more IP addresses, which IPv4 is not able to handle. It's not able to cater to the needs of public or devices. So there's a need to go into a different kind of scheme, which will give not millions but billions of public IP addresses to these devices and to us, right? Because using mobile phone and such devices was not a trend. It was a luxury at that point in time. I remember back in 90s, there was a phone, maybe 1.5 times size as this, right? There's a phone, and then you have an antenna as well. And then internet was still not there in it, right? And now everybody has a phone, and as soon as you power on 4Gs and 5Gs, you are giving a public IP address to this device. All right. So that's where we need IPv6, and that has 128-bit in size, whereas IPv4 is what? 32-bit. Okay. So going back to this discussion, there's a device out here, there's another device out there. Both of them have different IP addresses, 192.168.10.40. The crux of this discussion here is to understand how these two devices talk to each other, if they ever have to talk. But if this guy has to talk to google.com, does he really have to talk to that device or talk to the router? Right? So just like if you and I have to talk to each other, we just talk like this. Yeah. Where I don't have to walk out of this room and find a different door to talk to you, unless you are in that room. Yeah. Right? Now use this analogy as two different devices in two different rooms versus two devices being in the same room. Yeah? Or in the same network or different networks. So we'll do the same calculations for this guy. 192.168.10 is the same thing, so I'll be lazy and I'll use the same thing here. And this 40, what is 40? What is binary equivalent of 40? So we are using lazier means to calculate the binary equivalent of the decimal, which is, I'm using this calculator in a programming mode programmer mode,
Mm-hmm.
type the number 40 and it gives us this 00101000. Yeah, that's another way. All right. So now if we do the calculation, what is the value? It's still 0.
0. Mm-hmm.
And that tells me that regardless of what device and what IP address I do the calculation, I still get the same output. Isn't it? Yes or no?
No. Can you repeat the question? I'm sorry.
Yeah. So here I had 40 earlier.
Okay.
We converted 40 to a decimal value, multiplied it, we got 0.
Mm-hmm.
In earlier case, when it was 30, we still had the same output.
Same.
Output didn't change. And that means that whatever number you put here, 60, 70, 80,
0.
85, the output is still the same.
Yeah, it's gonna
All right. So this is my device, a laptop. And this is my laptop. Maybe a desktop, maybe a phone, whatever device. Okay? And this device A wants to talk to device B. They will do this calculation. And he says, hey, I've got this output. What is your output? I say, I've got this output too. Okay, looks like we both of us have the same last names. Are we brothers? Are we siblings? Yeah, we are in the same network. So let's talk to each other directly. We do not need this router. They can talk to each other directly because you and I are in the same room. I do not have to go out of this room into a different door and then find you because you're right here in the same room. Get it? But if this guy has to talk to Google.com, Google.com subnet will be something else. He will have a different network, different range. That's when he will go and talk to the router and says, boss, I cannot find out where B is. The router will then route and find where Google.com is. So if he can find things, he will talk to his partner directly. But if he cannot find, then his router is a go-to guy, which will then route the traffic out in the internet or in the intranet or in the LAN. Does that make sense?
Yep.
So all of these things are happening in the background in a fraction of a millisecond, very quick. Because of the kind of processing power we have today, right? Quad cores. This is i3 64-bit processing in mobile phones, which was kind of a dream 15 years ago, right?
Yeah.
64-bit processing. Even in computing was kind of very far when we think about 64-bit processing in computers. All right. You got this whole story?
Yeah.
All right. The router can also act as a firewall. What is a firewall? A firewall is a device that protects our traffic, our network from incoming traffic and outgoing as well. So let's say you've got 20 employees sitting here. Yeah, same old story. You've got 20 old employees sitting in this room, and you want to make sure that their productivity is calculated, so they do not use social media sites, or they do not use Gmail or any personal sites. If they ever have to use Gmail, they will come and sit on this computer, which will then have access to everything. So during their break time from 1 o'clock to 3 o'clock, they can use whatever, but as long as they are sitting here, they will be using productivity tools only, right? That's a scenario. So this is your production environment, 20 people sitting here, and you do not want these guys to access facebook.com. What do? You will go and set up a rule in the firewall.
Yeah.
You have to write the rule, because you know that any traffic, based on this theory, any traffic that is going out of your network is going to the router. And you can then ask the firewall to look at every traffic that is going out of this device, to look, intercept, and then either stop or allow. If it is stopped, the packets are dropped right here. If it is allowed, they just go out in the network. Make sense? So this guy will either see facebook.com or may just get a page cannot be displayed or a black screen, depending on that. Now you work in a bank, so
Yeah,
you know
it
not
happens
every site.
the same thing. Yep.
Exactly. So the firewall administrator writes the rules. There's a way to write the rule, because firewalls, again, just like computers, do not understand English. I cannot say, hey, do not allow Facebook. No. Facebook, IP addresses, these are again terms that you and I use, but firewall does not understand that. Computers, they don't understand that. You have to write in a particular way. And that way, that method is called a rule, also called as access control list. Access of what? Access of the websites or IP addresses, and you are controlling them, right? And over a period of time, you have a list. Facebook.com, Google.com, Yahoo.com, you're making a list, right? Allow, deny, right? That's an ACL. So there's a procedure, there's a method that you follow. What is that? You will write a source IP address, which is 192.168.10.30, right? Destination is facebook.com, okay, which is 192.168.10.30. Destination is facebook.com. Source, destination. You know port numbers?
Port, yeah, like I just printed out the stuff, like all the port numbers. I don't know. He asked me to look for it.
Yes,
So-
perfect. Yeah.
So that's what
This is very important.
Yeah. So he told me that it's very important, so I was just doing that today.
Yeah. These are important as a network admin from the exam perspective. Network plus or security plus, even in A plus, there will be questions on this, and even in the interviews.
Oh.
Yeah. So if I block port number 80 on your firewall, you will not be able to access any website, banking, nothing will work,
Yeah.
right? So every protocol has a port number mapped to it. There's a well-known protocols like HTTP. When you do www.google.com, it's HTTPS,
S, yeah.
which is 443, port number 443. When you do DNS queries, like www.google.com, that's something I understand. Computer again does. So it needs to convert that name to an IP, right? That is DNS. You can go ahead and pick up.
I'm sorry.
Yeah, go ahead.
My kids are asking
Sure.
me something. Yeah. Sorry.
So DNS uses port number 53. Okay. So it's important to memorize, and you'll get that in some time. You know.
Okay.
Okay. So you put the port number as well here. And I want to manage port number 80 and 443 because Facebook is https://facebook.com. Next, status. Do you want to allow or deny? Right. And then there's a change number or a remarks that you put, because this firewall is not owned by the firewall administrator. He manages it. He's not the owner. Nobody's the owner in a company. So if when he's not the owner, he has to follow certain change management protocols. So apart from this technology, all this bunch of books, you must also learn certain procedures. For example, this is your home, you've got a refrigerator out there, right? And then you know what to do. If you want water, you'll just go open, you know where water is, and you'll drink it. But for me, I'm sitting here, and if I know that refrigerator is there, I need to ask you, right? I need to ask you. Say, hey, go ahead and take it. That's when I'll go and take it. It's a procedure. Because I know where it is, but I don't know how to manage it. Is there a button? Is there a lock? Is it shut down? Is there water in it? Or the refrigerator is probably something else, or probably somewhere else in a different room. Or if I open, maybe 10 things may fall down, right? There are a lot of things. Dependencies, right? In a company, if any modifications to any device must be done through a change management, which is a document, which is simply a document, which people write it and say, here is a change I'm going to do at the following time, on the following day, at the following time, and this is a step 1, step 2, step 3, step 4 procedures. If step 1, 2, 3, 4 goes wrong, this is the backup plan, and here is a technical manager, and I submit that change. And then that request goes to the approver. He then looks at it and then identifies, are there any dependencies? Is there somebody else doing the change at the same time? Because there could be 2 or more firewall administrators doing the change at the same time. You know what I mean? Right? So you'll put the remarks here so that you are safe. Any change, could be a small change like restarting a server. Restarting the server is not a small change. But let's say installing a patch. So changes must be authorized by the change, is something called as CAB, C-A-B, Change Authority Board, that will sit sometimes on a Tuesday or on a Friday. They'll sit together and look at all the changes enterprise-wide, company-wide. This change approved, this change approved, this change approved, this change disapproved. I will disapprove it totally. So when my change is disapproved, I'll go back and say, why it is disapproved? Probably I'll just call him and then talk to him why he disapproved it. You know what I mean? So change approval is only a document. It's a procedure, not a technical thing. So if I do this, source is 192.168.10.30, destination is facebook.com, port number 80 and 443, I'm denying it. Next day this guy walks in, what will happen? He'll not be able to access facebook.com. 30.40, 30.60, 30.31, and all those 20 devices. You're going to put them one after another. Clear? What if there are 50 devices? We'll put 50 ACLs, 200 ACLs. Your company grows. Now there are 600 people sitting in this building. And then you have to buy another building out there. There are 1,000 people now. You will write 1,000 rules here. Difficult, right? Difficult to manage. Difficult to manage. And remember one more thing, that if I get an IP address of 10.30 today, tomorrow I may not get the same IP address. It rotates. We'll talk about dynamic allocation of IP addresses later on, dynamic and static IP addresses later on, but IP addresses are not static. For example, my phone is lying here. I'm not connected to wireless. My laptop is lying here. I'm not connected to your wireless either. But if I ever have to connect to the internet, I will ask. Connect to the Wi-Fi, you'll give me the password. Who is giving me the IP address? Your wireless device, right? Let's say you are giving me an IP address of 10.30. In about 2 hours, I'm gone, right? So I've connected my laptop and my phone. Now because you gave me the password and you're broadcasting the IP address to me, so he also connects to his phone. So you're losing like 6 IP addresses right away, isn't it? This phone, that phone, this laptop, his phone. So six IP addresses you're losing. Probably projector also has a network card. So out of the 255 IP addresses you're giving, 6 IP addresses you're losing. Yeah?
So every device has a 255 IP address?
No.
Like a router has a 255?
No, every device has only one IP address.
Yeah.
It is the router which has the ability to distribute IP addresses. How many? Well, you as a router admin can configure. By default, 255.
Yeah, that's what I'm saying. By default, it comes like 255. Okay.
By default, the SOHO routers, small office routers, Netgear, whatever we're buying off the shelf from the internet, from Amazon.com, when it gets shipped to your home, it can give 255. But can you modify it? Yes, you can.
Oh, yeah? Okay.
Yeah, you can log into the router and modify it. Okay? So today I'm here as a guest, tomorrow someone else, maybe you want to learn different class, maybe. So everybody is consuming like 6, 5, 3, 2, 1 IP addresses. In few days you're done. Isn't that a problem? That is a problem?
Yeah, it is
Maybe
a
your kids' friends will come in and say, hey, can you give me the IP address? Connect? Yeah, they will get connected. And then you're losing IP addresses. So
Okay.
the IP address allocation must not be static in nature. It must not be static and it must be based on a lease. It says that, okay, I'm giving you the IP address, but only for certain duration of time. It's not with you forever. Right? So when I do IP config / all, you will see the lease period as well. By default, it is 24 hours. After 24 hours, the IP address can be allocated to any other device.
Okay.
Yeah? So that is the problem we are talking about. This guy who got 30.50 gets into office the next day, and now he gets 10.31, and 10.31 is not in the list. Probably 10.31 is not in the list. So he is now able to access facebook.com. Problem? Is it a problem?
Yeah.
Yes. That's the first problem. Second problem is when we have like 6,000 people working in our network, or 600 people. You cannot have the network admin write the rules every day. Right?
Yeah.
So what if we have a simple notation that represents my entire network? A notation, a symbol. Just put it there and it represents my entire network. Instead of writing ACLs in the form of IP after IP after IP and after IP. Does that make sense?
Yeah.
So you're noticing that we had some problem, we are solving it, now we have a problem, we're solving it, now we got another problem here, and we are trying to find out the solution. Yeah? So, entire IT has evolved like that. We as IT enthusiasts do not create applications or devices just for fun. There are some people do, but most of them that you see around us, they are solving a problem. Yeah? So, we are also solving a problem here. In fact, somebody else did, we are discussing. We're just talking about. So here I'm going to put a notation which is called as a block. So instead of an IP address, instead of a range of IP address like this, I will put a block of IP addresses, which is also technically called as CIDR block. CIDR is an acronym which stands for classless interdomain routing. So I'm going to put a block of IP address here. That any IP address that falls under this block will have to follow this rule.
Oh,
Okay? So instead of putting the IP address, I'm going to put IP address and subnet mask, a combination of this and that. Okay? So I'm going to erase the top part of it just to make some space. Okay. So what is the subnet mask for this guy? 255.255.255.0. Okay? Alright. How many ones do I have in the subnet mask?
How many ones?
Do I have in the subnet mask? 8 ones here. 8 ones here.
8 ones,
here.
yeah.
Yeah, 24. Okay? That tells me that this part is constant. This part is constant. Did you notice that whenever we talk in IP addresses, we are keeping this part as a constant and this part as a variable. We said 192.168 at 10 dot something, 10.10, 10.20, 10 dot something, 10 dot something, 10.220 or something. But this part is also always constant. That means all these devices in the network will always have this first part as a constant. So this part is the network ID. Right? This part is a network representation. And this part is the host ID. Host is nothing but your device, your phone, your laptop, your projector. Any device that gets an IP address is a host. And hence it's called as a host ID. So in your IP address, there are two segments. One is the IP address, one is the network ID, another is the host ID. Yeah? So whenever you see 255, hey, look at this name. What is the name of this? It's called a subnet mask. When you say mask, it means you are hiding something. If I put a mask of a Spider-Man, I'm actually hiding my actual face, right?
Yeah.
Or appearing like a Spider-Man. But I don't have any such attributes. So it is masking which part? It is masking this part, right? And this, here it is open, and hence this keeps on changing. Yeah? Okay. So in order to put my block here, CIDR block here, I'm going to first type my network ID and say .0/24. The 0 part is a variable, the last part, and when I say /24, it means the number of ones I have in the subnet mask. So if I erase all of this, just everything, and keep just this part on the board, 192.168.10.0/24, you actually write it on a piece of paper and give it to a network admin, he will understand quite a lot of things. He'll say, okay, you're giving me this. Looks like you got 24 ones in the subnet mask. And you put 24 ones like this, which is 8.8.8. So that is, first 8 dot is 255, the second 8 dots is again 255, next 8 dots is again 255, and the last part is 0, so, okay, so I got 24 ones. So this 24 represents the number of ones I've got in the subnet mask. Yeah? Alright. So what is the network ID? Because I've got 24 ones, I've got 255.255, the first part, which is 192.168.10, then becomes the network ID. The last octet is the host ID. Clear?
Yeah.
Okay. 192.168 10.x. So how many devices can I have in this range? If you have this configured in your device and you are hosting a party here where about 200 people can be accommodated, can all of them get connected to the wireless router? There are 200 people in this room. Let's calculate. We don't know yet. Let's calculate. So I'm going to go from 192.168.10.0, 10.1, 10.2, 10.3, 10.4, all the way up to 255. Remember, it cannot go beyond 255.
Yeah.
Yeah? Yeah, because 255 is all ones. 256 is something else then. Okay. So how many devices am I getting? 192, 168, 10.0, 10.1, 10.2, 10.3. How many devices am I getting here? 256.
0 is all.
0 is also there. But computers do not assign 0 and 255 to any device. They do not assign it. You may ask why? Minus 2. 0 and 255 is 255, so 254. So technically and theoretically, we can assign 254 IP addresses when our CIDR block is 192.168.10.0/24. 254 devices. Yeah? So 0 is not assigned to any device, 255 is not assigned because 0 is used by the network itself and 255 is used for broadcasting purposes in the network. So if the router ever has to broadcast, if that device has to broadcast something, tell all the devices here do something, then it will use 0.255, sorry, 192.168.10.255. So 0 and 255 are not assigned, minus 2, 254. So technically you can have 254 people partying in this room connected to the same wireless router. Somebody carrying 2 phones, you can say not allowed. Is this theory clear?
Yeah.
Okay. So we're doing a capacity planning here, and if you ever have to lay down cables and whatever, straight cables or cross cables on the floor and connect different kinds of devices, you now know that this range will give you 254 devices. Yeah? But what if I want more? What will I do? I got 300 devices. What will I do? Just change the subnet mask.
Oh, yeah.
Just change this, because you're saying this is the host ID. Okay. What about now? What is the CIDR block now in this case? 10.192.168.0.0/16. 8 plus 8. Make sense? Confusing?
Little bit like. So you said if we have more devices, so
the devices, the number of devices are governed by the last octet in our previous example.
okay.
Correct? In our previous example. The last octet is controlling that because the network ID is this part and that part is a host ID. Now I'm extending my host ID and saying that, okay, you along with this octet is also host ID. So this time my network ID is this 192.168.x.x. So both of them will be host IDs. So it goes like this.
That are available for you to configure. The host IDs you can configure. You can give it to assign it to some device.
So now you can go like this 192.168.0.1, 0.2, 0.3, 0.4, 0.5, all the way up to 0.25. And this guy changes 1.1, 1.2, 1.3. Again you got 254 IP addresses, 2.1, 2.3,
Okay, I got you.
another 254 IP addresses. So if you look at the permutation combination, you are actually getting 254 multiplied by 254 devices.
Oh, okay.
Permutations of this and this, all combinations, you're getting approximately 65,000 devices. Isn't it?
Yeah.
So, you know about this whole thing is called as subnetting. 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 So you got classes of IP addresses. You know what's a loopback IP addresses? Did I tell you loopback IP address?
Yes, you did.
No, I think we deviated from there to ping, and then we did not come back. I just said
10 minutes, yeah.
I just said loopback IP address is this, and then we spoke about drivers, and then we moved somewhere else. Okay, so this is used for troubleshooting purposes. 127, the whole series is used for troubleshooting purposes. Your device need not be connected to the internet. So if I ping 127 range, what will I get? Ping 127 dot something. Cannot see that, but it is pinging, right? Do you see this?
Yeah.
This is ping, P-I-N-G, 127.0.200.4, just any IP address.
Right now, yeah.
Oh, better.
Yeah.
Better for me. How about you?
Yeah, I could say it.
Okay.
Yeah.
It says reply from this IP address. My device is not connected to the internet, you see?
Yeah.
It's not connected, right? But I still get replies. But who's replying? The network card itself. This packet does not go out of the computer at all. It just goes out to the network card. It says, hey, are you alive? Are your drivers working properly? Are you okay? Is your health status okay? So it just checks the green or orange for the network card and finds out its health. That's all, right? So you can ping any series. It's a basic minimum check. Sometimes we pinch on the hand and say, hey, is it real? It's exactly what it is. We are pinching the computer and finding out if the network card is happy or not. So just like knock on the head, yeah, I'm alive. Yeah. Okay, so I think we had a good conversation here, yeah?
Yeah.
With cloud, nothing has changed. Cloud is just a way to create virtual machines and different kinds of devices somewhere else. Traditionally, if you want a computer, what will you do? You go and buy a computer, right? But today we don't have to buy a computer. All you need is internet, and you can create computer somewhere else. Get your job done, switch it off, and you pay for just that amount of time instead of paying thousands of dollars to Best Buy and Dell. Yeah? It's about saving money. That's what cloud is all about. But IP addresses, networks, subnet masks, they are the fundamentals which will live as long as we exist and the earth exists. Yeah.
आपके लिए कुछ lunch order कर दूँ? Sure. I have my son is here. He can bring it. Pizza का कुछ भी sandwich का, हाँ?
नहीं मैंने कहा के आया था हम बाहर जा रहे हैं.
Sure.
Some other time.
Okay.
Maybe you teach us home sciences. Alright. Anything else I'm missing here?
No.
Okay. So all these numbers, mathematics, calculations, where are we going to use? How does that help? Let's talk something about it. Okay. In real life, you have to do capacity planning. You know about all these calculations, mathematics, but the crux of this conversation from now onwards is to know where can I take this knowledge in the real world. How do you create networks? So you assign me a task and say, Anand, walk into this room and you see this floor all the way from north to south. We are laying a data center here. In that part of the room, we need another 250 people residing out there, right behind this pillar. We need 200 people out there. And all those 200 people are connected to this data center. You understand data center? Being in the bank, you might have seen, or maybe walk pass through the transparent cabin, you'll see red and green, blue lights blinking on and off. That's what a data center is. So in this aisle, you have data center. On the other part of it, you've got 200 or 2,000 people sitting. All of them are connected to this data center, and the traffic that they are sending will be going through this data center out to the internet. Any traffic that gets in will come from the internet to this data center and then to those devices. So this aisle or this floor from north to south is acting as an intermediate data center, intermediate network between my intranet and the internet. Intranet is within my network, internet is outside my network. internet. Yeah. So that's the task. So now that you know there are 250 people connecting, you may ask further questions, right? Or I will ask further questions because you are assigning me a task. You will say, or I will ask, is there a further segregation between the people? Like 100 people should be able to talk to 100 people, or those 100 people should not be able to talk to other people? Is there a wall out there? When I said talk, I'm talking about these devices. They should be able to communicate or should not be able to communicate. Because in certain offices, you will have internal segregation where this part, who is doing a healthcare business, should not be able to talk to the banking segment. Yeah? Because there is no business between healthcare and banking. There's no communication that's required at all. Nothing. But they are in the same floor. They are in the same aisle. Make sense? So you say, yes, this set of people should not be able to talk to that set of people. Okay, then you need certain segregation done. Total segregation. So there are people sitting out here with their laptops, desktops. There are people sitting out here with their laptops, desktop, and different devices. And this is the floor. And you told me that you need capacity for 250 people. So there will be 250 wires going to each point so that people can take up or pick up that wire and connect to their respective laptops and desktops. Sometimes you may have 3 of those connections per desk. Since you have worked, you know that there's a connection for that Avaya phone, Avaya Cisco phone, 1, second for the desktop, and 3rd for your laptop. Sometimes every person gets 3 connections. Now that era is changing actually, because now bring your own devices. No more desktops. No more desktops. Just laptops.
Yeah.
No more Avaya phones and Cisco phones. You have soft phones installed on your laptops. Okay. So you are saying that 50 people sit here in the healthcare section, and then another 200 people sit here in the banking section. But they are in the same hall, the same building. All right. So when we have to do capacity planning for them, you always add like 30% extra because people can join, companies can expand. Another 30%, you may say like 70 people here and like 250 people here. Although they are physically 200 people, but I want to have capacity planning for 250 people, okay? So we are doing the reverse way now. Reverse way is, now I know the number, I need to know what is the subnet for this. Remember the CIDR block? So if I put 192.168.30.0/24 for this, are you happy with this? With /24, are you gonna get 250 plus devices? We are actually getting 254.
254, yeah.
Still happy? So if I assign CIDR block of 192.168.30.0/24, I'm gonna get 254 devices, which makes my banking segment happy. Good. Now my healthcare subnet. I need to have something smaller. So if I do 192.168.30.0/28 will give me 11 IP addresses. So the larger this number, lower the number of devices you can have. Yeah. So you have to fit somewhere between 24, 25, maybe 25 should, maybe 26/26. Does that make sense?
So it's going to give you less numbers of the devices?
Less of devices. If this number is more, less devices. This number is lesser, like 16. 192.168.00/16 gave you 65,000 IP addresses. So lesser that number, more IP addresses you will get. So it is inversely proportional. So that's why we need that knowledge to create data centers at this scale. You can then create multiple subnets. Remember that this is the whole room, and this entire room will also have a CIDR block. 0.0/16. This entire room. That means for this entire floor, 3 floors or 4 floors, I can have 65,000 devices, but in each room, I can have 70, 30, 200, 500 respectively based on the IP, based on the CIDR blocks that I've assigned to respective subnets. This is a network, and these are subnetworks. Subnetworks are also called as subnets.
Mm-hmm.
All right. Should we go to cloud?
Yeah.
So this is how networks were created, and we are now moving from this kind of network implementation to cloud. Cloud is where I really do not have to do a lot of capacity planning like this. It's quick, fast. Because if I ever have to create a data center in this room, it will take months. I have to contact different kinds of vendors, contact a carpenter to raise this floor by 2 feet for ventilation purposes. Contact the guy who can drill this all the way out to the atmosphere and let the cabling get in, right? So it needs a lot of coordination between people. When I say people, it is within the IT departments as well, because you need a storage administrator, you need a network administrator, you need somebody physically fit who can pick up those racks. 15 years ago, when we had to look at the job descriptions were something like this. It said, hey, gotta be MCSE, at least an MCP. You need to know the fundamentals of TCP and IP. You need to be an CCNA and all that. And finally, you must be able to pick up at least 50 pounds of weight. Because now you need to pick up those racks and then pull it back into the rack. So that's kind of a cumbersome and heavy activity. With cloud, you don't need to be, so you have to be physically fit always, but you don't have to lift anything. Okay. So we are moving from this kind of environment to, that kind of environment to cloud. Is the font clear for you?
Yeah.
You're sitting diagonally, so.
No, I'm
okay.
fine. Yeah. Thank you.
Okay. Okay.
Do you want to get a chair or anything? I have an extra chair too. Okay. Are you okay?
I'm okay. I'm actually a trainer, so I'm habituated to stand for 8 hours at a stretch.
He told me that, yeah.
Okay.
Thank you for coming though.
No problem. So this picture out here represents a data center.
Okay.
And when I said that the floor must be raised by at least 2 feet, that's where the gap is.
Yeah.
These black boxes are racks. This blue area is a cold aisle for ventilation purposes. So there's a gap between each rack. The other areas are for signals and systems, for monitoring purposes, earthing, heating, ventilation, air conditioning. So there's a lot of investment that goes behind it. Initial amount of investment. When you want to purchase a house, you pay a certain amount of money. You want to buy a car, you pay a certain amount of money initially, and then over a period of time you have operational costs like what? Taxes, monthly taxes, you have utility bills, all of that. In IT it is no different. You pay the same thing. Administrative costs, salaries, heating, ventilation, air conditioning costs, it all goes along with it. 15 years ago, large companies could afford it. Governments could afford it. People who had ideas, new ideas to develop new applications, well, they really cannot afford that kind of a data center. Like for a single person like me, and I have a great idea because I play games all the time on my computer, and I have a new idea of creating a new game, and I think that, okay, this game will create a new buzz in the market. I cannot build the game myself. Even though I'm a good coder, I cannot do that because I don't have the hardware. I don't have good graphics. I don't have 64-bit computing. So my idea will just evaporate with period of time. And that's when cloud comes to rescue and says that, hey, your idea doesn't have to sit idle. You can come to the cloud and create virtual machine of any kind, any power, any storage, CPU, memory, whatever you want. Just throw it at us and we will create it for you on the fly. Right? Doesn't take months, doesn't take weeks, doesn't take days, hours, not even hours, minutes. Between 4 to 7 minutes, a machine is ready for you. Just log in and start writing your code, do whatever you want. And once you're done with your activities, shut it down or delete it, and you pay only for that amount of time. Great, isn't it? It's just like, I want to buy a Lamborghini, but I cannot, right? So I'll go and rent it.
Yeah.
Paid for whatever time I use, done. And that's how the concept of Uber is as well. I cannot afford a car, but I can definitely use a Uber and pay him like 20-30 bucks, and it takes me from point A to point B. Job done. Do I own a car? No. Am I responsible for maintenance, oil change, gear? Nothing. Not responsible for it at all. Similarly, here in cloud, I as a cloud user, I'm not responsible for quite a lot of things, but I am responsible for a few things. And that thin line must be understood. Because if I keep my intellectual property, banks for example, if I keep my customers' bank statements in the cloud and they get compromised, they get hacked, who's responsible?
Bank is
Bank is responsible or I am responsible? Let's understand that slowly moving forward. But since we are talking about cloud, what is the definition of cloud? What is cloud computing? Definition. Who is giving the definition? Is there a regulation? Is there a, like in banks you use PCI-DSS or GLBA, which is Graham-Leach-Bliley Act, which is primarily for regulations of your finances and banking transactions. So when I swipe my card somewhere in Walmart, they must be following certain regulations so that my information is not sent out to some third party who's malicious, right? It must be with Walmart itself. Or the transaction must be so transparent that Walmart sends that information directly to the bank and then gets and says yes or no. Is it valid or not valid? That's all. Walmart has no information about my first name, last name, my CVV or 16 digits of my code. They should know nothing about it, right? Because they have no business with it. So that's PCI DSS, a kind of regulation. Similarly, when we think about cloud, there are so many vendors in cloud as well. You know, Amazon Web Services is one of the vendors. Azure is a vendor, Microsoft itself. Google Cloud, Rackspace, DigitalOcean, HP, Fujitsu, IBM, Accenture. It's a cloud war going on. And 20 years ago, the war was between the hardware vendors. Dell was producing machines, IBM, HP, they were producing machines, network cards. And there was a regulation which was given by, again, IEEE and NIST. And they said that if you want to create network cards, you need to follow OSI, ISO. Have you been through that? OSI layers, right? Network layer, data link layer. So that meant that proprietary devices can still talk to non-proprietary ones. Like Dell machine, that is an Acer laptop, can connect to your Netgear device. This has a network card, that also has a network card, but it can still talk to both of them, although the suppliers are different because they are following standards, right? So if you follow standards, what will happen? Devices of dissimilar nature can talk to each other. Does that make sense?
Mm-hmm.
Yeah. In cloud also, there's a standard given by NIST, and it said that, hey, you provider, if you ever want to create cloud computing, you need to follow my definition. What is a definition? Well, definition is as simple as follows, right? It just says cloud computing is a model for enabling ubiquitous, convenient, on-demand network access. Well, just park it for a minute, right? So if you are able to create, the whole idea is to create a resource. A resource means a virtual machine. You know what a virtual machine is? A physical machine. That's a physical machine in which everything is physical, in the sense the memory you can touch, feel and see. The keyboard, the monitor, the motherboard, everything is physical. And virtual, everything is virtual in the form of files. The hard disk is a file, the CPU is a file, the memory is a file. Everything that you can touch, feel and see is virtual in nature. It's in the form of a file. We'll talk about it in a minute, in the next slide. So you can create anything in the cloud, and if you are able to create a resource from anywhere at any point in time with minimal intervention from your provider, is cloud computing. Understood?
Mm-hmm.
If you are able to create a resource from anywhere, when I say anywhere, it could be from your home, could be from a subway, could be from the airport, not while driving, when you are wherever, as long as you have internet and as long as you have a device that supports the browser, that's all, right? From anywhere, at any point in time, in the middle of a night, wherever. With minimal intervention from the cloud provider means I should not be calling Amazon, stand in the queue and say, hey, you're customer number 98, right? There's nothing of that sort. So I'm not calling customer care at all. I'm creating a virtual machine just by logging onto the interface. Just like you can transfer funds using the net banking interface from anywhere at any point in time, you should be able to create resource just like that. I do not need to call my cloud provider for that purpose, right? Now if you read this, it says cloud computing is a model for enabling ubiquitous, convenient, on demand, on my demand, not on their demand. Cloud providers should not say that, hey, my shops are open only from 9 to 5. If you ever want to create a resource, make sure you do it before 4:49 or 4:59. It's not like that. This is on your demand, network access to a shared pool of configurable computing resources. What is a computing resource? A network, server, storage, application, anything in the cloud that can be rapidly provisioned and deprovisioned. This is released. That means creating and destruction can be done with minimal management effort. That means even I must not be putting a lot of effort in creating these resources. I do not want to contact my service provider like Amazon or Azure to build any of these things. That's the definition of cloud computing. Now this is given by NIST in their publication 800-145 in September 2011. Yeah? I have already recorded this video for Azure. Maybe you can give that video. Yeah? I have these recordings.
Oh, okay.
Yeah. Have you heard of Udemy?
What is it?
Udemy, like Academy, Udemy.
I heard it, yeah.
Yeah. So I publish videos for them.
Yeah, you told me that, yeah.
Okay,
yeah,
so I'll share the videos with
okay,
you.
perfect. Thank you so much.
So here we're looking at how cloud has evolved over a period of time, how information technology has evolved over a period of time. I thought there's somebody, it's me. It's a mirror. So it's like 1, 2, 3, 4, and finally cloud. So we'll spend some considerable time understanding this.
Okay.
The first block, traditional data center. 20 minutes ago, we were talking about traditional data center, setting up data center in this aisle. Yeah. In India, at least, IT came about early 90s when our Rajiv Gandhi was the Prime Minister at that time. And he said that we're gonna change all of these files and folders to computers. So all of them will just go in computers. So okay, great. A lot of people benefited from that, specifically organizations that had a lot of money, like TCS, Infosys. They were the ones who could build data centers. They were the ones who already had an establishment of network and infrastructure across the globe. And private manufacturers also benefited from that because they could then supply to governments. But nobody else could bid because hardware was expensive, right? Even at that time, the dollar cost was about 24 rupees, right? And if you're spending like, let's say $10,000 per box, you need 10 boxes to build a bare minimal data center. When I say 10 boxes, you need one box for, let's say, Windows, another box for Linux, another box is a database, and then you will need RAID. At least 10 boxes, you're spending like $100,000, which is like 24 lakh rupees, which is even in today's world, it's a massive amount. At that time, when Rajiv Gandhi was the Prime Minister, 24,000 was so voluminous amount, you know that, right? It's massive. And who can afford it? For few people, it was very small, and they were like large giants, governments, it is small money, right? But then if people like me who would like to build such data center, I will just maybe drive an auto rickshaw or something. I don't want to do any of such business, which is out of my coverage area, rather to say that. So traditional data center was that cumbersome, not everybody's ball game, right? So we then moved on to virtualization, virtual. Have you heard of virtual reality, VR?
Yeah.
So if you take your kids to the game or some kind of game, so they have these glasses.
Yeah.
You wear those glasses and you feel as if you're flying somewhere, you're in the middle of a mountains, and sometimes there's 3D effect, the water actually splashes on the face because you're almost close to the ocean or something. Yeah, that's virtual reality. Using that as an analogy, virtualization is close to this, where you need everything in physical kind of setup here, but here it is not physical in nature. You will have the physical world, you will need the physical hardware, but let's draw some pictures here.
It's fine. I can see it. If you don't mind, yeah, I'm comfortable. Lights in comfortable, so you don't have to go back and forth. Yeah. Perfect. Yeah.
So this is your physical box on which I have like lots of memory, 256 GB of memory, lots of Xeon processor. By the way, Xeon is a server-based processor. Regular laptops and desktops will have i3, i5s and i7s. In production environments, you'll use Xeon-based processor. Xeon, even with 2.5 gigahertz, is fast. 3.6 is massive. Okay. So you then connect it to a powerful hard disk, which is like petabytes of storage. Now this is your physical box. On top of this physical box, what you're doing is creating a layer called as hypervisor. Make sure we create that VMware Workstation and Oracle VirtualBox. So hypervisors, you create this hypervisor, and on top of this hypervisor, you create virtual machines, VM1, VM2, VM3, VM4, etc. Traditionally, what used to happen, you get a hardware like this, install operating system, right? But now you can install a hypervisor and then create multiple virtual machines of dissimilar sizes and then operating systems. This could be Windows, this could be Linux, this could be a Windows different flavor, this could be, this is Linux what, SUSE, and this is Red Hat. So these virtual machines that are running on the same hardware, make sense?
Mm-hmm.
They do not have their hardware of their own. If they ever need certain memory, they'll contact this guy. They need certain CPU, they contact this guy. They need hard disk, they'll contact this guy. Yeah?
Yeah.
So this is hypervisor. Isn't this saving a lot of money? As opposed to the first box,
Yeah, little
where
bit more, yeah.
I had to buy a real physical box. Real physical boxes. Windows, Linux. 4 boxes, which is like $10,000 each. I'm spending 40K. Here I can just have one hardware on top of which I can have. But also keep in mind that when you buy this box, you have like 4 gigs of memory and 2 CPUs. You never use the whole thing. So if we buy a 4 liter car engine, do we ever use the full capacity? You say it is okay 2000 cc. Do we ever use the whole 2000 cc? This car can go up to like 250 miles per hour. Do we ever use the whole thing? No. So we should not be using it though. But here in this case, you're still investing on that 4 GB of memory. You're still investing on the 2 CPUs. So your investment is done for this. But the application that is installed on this, it never utilizes the whole. So optimum utilization of resources is not done here. Your investment lies idle. In this case, optimum utilization of resources can be done. So it's like what you buy is what you get. But you still need to invest on this box.
Yeah.
You still need, this is expensive. This is not cheap, this is expensive. Fine. But at least I don't need to buy 4 boxes. I'm also saving my real estate, which is again going higher. So we moved from traditional environment to what? Virtualization. So in virtualization, the vendors are Hyper-V from Microsoft. You may ask, how do I create this hypervisor? How is it created? Is it an application? Is it a software I can download and that lets me create a hypervisor? Yes. That software is called as Hyper-V. Who made it? Microsoft. Another one called as VMware. VMware also has different versions of it called ESX. So VMware ESX, this was actually one of the first ones, and then came Microsoft Hyper-V. So that happened back in 2003, where VMware created its hypervisor, named it as ESX, and the version was 2.5 at that time. Today we are running at 7, VMware ESX 7, and that was a well-paid job. Whoever knows VMware virtualization were paid pretty high at that time. Does that make sense?
Yeah.
So there was a problem, we solved it with this.
Yeah.
There's a problem here,
Still
we
is
move on
more
this.
expensive, yeah.
Still expensive. Still expensive. When expense, okay, I'll say, okay, I can afford it. I can say, I can afford it, why not? I don't want to go and get my Lamborghini on Uber. I'll go to the store and buy that Lamborghini thing. Okay? But the problem here in this case, there are companies, yes, I don't care about money. I have a lot of banks have like, they are like cash rich. No problem. But then the problem here is that maybe the guy who wants to buy a Lamborghini, the country there is not offering him that kind of roads.
Mm-hmm.
Speed breakers are too high. A lot of people on the road.
Mm-hmm.
The roads are too narrow and curvy, so just bumps everywhere. What's the point of buying it then, right? All right. So the problem here is something else, a serious problem. This whole thing, hardware. Companies have two kinds of people. One is developers, other is the people who manage this infrastructure, the infrastructure team or the administrator. There are two sets of people, minimum two sets of people, the developers and the administrators. So if the developers ever want to host their web application, they have to contact the infra team, which is us. The infra team will say, okay, we'll create it. Again, like I said about the ITIL procedures, I spoke about change management. And in this case, he has to follow a request management. That is done with the help of a tool called as ServiceNow. Right? ServiceNow is a tool. So the developer opens the tool and says, hey, can you create a virtual machine for me with whatever size, whatever hard disk, and says submit. The request comes to that team. Remember, he is not the only guy who's creating requests. There's a whole lot of developers who are creating the requests for the infrastructure team. So he is like piled up with a lot of tasks with him. What will happen? SLAs will breach. SLAs are service level agreements. They will breach. And when that breaches, then reputation of the company is at stake. It's a negative reputation because this team is not able to deliver services to that team. So when I'm not able to deliver services to that team, he cannot deliver services to his customers, right? So reputation is at stake. What if he could create the virtual machine by himself? You say how? Because the developer has no knowledge. Developer has no knowledge about infrastructure. He doesn't know what is an IP address. He doesn't know how to install an operating. He's very good at HTML and writing the whole code. And infrastructure team has no knowledge about the development, so there's a big gap between the knowledge of the two teams. So when I use this, the string or the phrase said that the developers, why don't they go ahead and create the infrastructure themselves? How is it even possible when they do not have the knowledge? Well, the private cloud is creating a simple web interface for them, where the developer has to log in with his user ID password. He gets another interface once authentication is complete. And he says, okay, now create a virtual machine. Click, 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 next, finish. Very easy interface where he could create infrastructure for himself. As soon as he clicks on finish, pop, he gets an email saying your virtual machine is created. Here is the IP address, here is a username and password. Isn't that simple? Makes his life easy. No dependency. Time to market. The whole idea of going to the cloud is three things. One is capital expenditure, reduce that. Operational expenditure, reduce that. And time to market, reduce that. If I as a developer have to make a game or something, and if I'm dependent on this kind of environment, then it will take a lot of time. So time to market is high. So as we move from this part to this public cloud, you understand these terms, CAPEX, OPEX? CAPEX is capital expenditure. Initial amount of money that you will invest when you want to buy a car, this is the money, right? That's a CAPEX. But after buying the car, fuel, monthly costs, insurance, taxes and all that, that is nothing but operational expenditure, month on month, week on week, daily costs. Time to market is the amount of time that you will take to publish your application out to the market. It's time to market. So with the approach that I just said, where the developers could make their own applications whenever they want it, then that is private cloud. Actually, if you go back to the definition of cloud, what does that say? That I should be able to create a virtual machine whenever I want it with minimal intervention from the provider. Who is the provider in this case? The infrastructure team. And I is that guy. So he can create the infrastructure whenever he wants it with minimal intervention from the provider. That is cloud computing. But in case of private cloud, the infrastructure is within the office, is within your bank. Make sense? So this is a bank,
Yeah.
that's the data center, that is the infrastructure team, that is the development team. The development team opens up that browser, says file, new, next, finish, he gets a virtual machine, but he's connecting to the infrastructure that's right here. It's not outside somewhere with Amazon or Microsoft. Hence the term private.
Private cloud.
But because he's able to create infrastructure whenever, wherever he wants it at any point in time with minimal intervention of the cloud provider or the infrastructure provider, is complying to the definition of the cloud as given by NIST, it becomes private cloud. Does that make sense?
Yeah.
So you understand this, the problems in each of them and why we are moving from A to B to C. Yeah? Alright. We'll talk about this. Public cloud. Public cloud is where the infrastructure is in somewhere else, is with Amazon, is with Microsoft Azure, is with Google Cloud, is somewhere else. It is not in my office. So if I want to create a virtual machine, like this, what do I need? I need internet. I need a laptop like that, or you need a phone like that. Just log in, type your user ID, password, and your virtual machine is created. That's public cloud, where my infrastructure is somewhere else, right? Got it?
Yeah.
In private cloud, the infrastructure is in the
same
office.
Building, same building.
Perfect. A combination of this and that is hybrid cloud. Where a bank like yours, bank has sensitive information, so they will not choose public cloud. But if they ever want to do testing, they'll say, hey, let's keep that small web server out there, which is not sensitive, which is not classified. I'll keep it there, but all the database connections are in-house in my premise, right? So part of my infrastructure is in my private cloud, another part of my infrastructure is in the public cloud. A combination of this and that is hybrid. Just
So
like
bank will use the hybrid cloud?
banks may use the hybrid cloud. Banks may use it. Yeah, they use. So the bank is working with Société Générale. Have you heard of it? So it's a French-based bank company. They use hybrid clouds.
That's what I'm saying. Like my bank maybe use the hybrid cloud because
Clear? So public, private, and hybrid. Okay. Cloud models. So going to the cloud is becoming a buzzword as well as a norm, but not necessarily all applications fit in the cloud. So we as cloud administrators decide what applications go in the cloud and if they are fitting in the cloud, yes or no. Cloud models are categorized as these three predominantly: SaaS, PaaS, and IaaS. SaaS stands for software as a service. PaaS stands for platform as a service. IaaS stands for infrastructure as a service. So what is software as a service? So when softwares are delivered to you on your browser, so let's say you have a business. And for all transactions, incoming and outgoing, you got a software called as QuickBooks. QuickBooks, there's a software called as QuickBooks. And that is installed on that computer out there. So every time you want to do a transaction, you power on that computer and then you write the transactions in it. Done. At the end of the year, when you want to file the returns, you have got all the ledger books out there inside it and submit it. But you again, as a business owner, had a problem of maintaining that server. Who will maintain that server? Power supply must be constant. It must be maintained in a particular temperature. What if the hard disk goes wrong? Maintenance of it. What if somebody hacks it? Right? So those were the headaches that you had to go through. So now you chose cloud. You said, I will migrate all of that data to the cloud. And then instead of accessing this particular server, I'll simply do http:// your company name .quickbooks.com. Type your user ID and password. And then you can do all accounting statements out there in the web page. Right? So you do not have to come home, connect to this machine, and then do the transactions. Now you can do all those transactions from anywhere sitting in the world. Because this is in a LAN. That thing is in the cloud. When it's in the cloud, you can access from anywhere. That's an example of SaaS. Do you need to install anything on your phone or on your laptop? No, just do HTTP from the browser itself. Yeah. Other examples are Gmail. Gmail is not at my home. It's in the cloud. So regardless of what device I use, could be my phone, could be my university kiosk, could be the kiosk in the airport, or the laptop, maybe my friend's desktop, whatever. You can access it from anywhere, isn't it?
Yeah.
So with software as a service, what do you need? You need a browser and internet. That's all. Facebook is also software as a service. I don't need to install anything. ServiceNow, there are a lot of examples that way. Anything that you can access through a browser is software as a service. I don't need an application, I don't need a plugin. Right? Okay. Now, you know about these exam results, right? Exam results that appear on a web page. On the web page, you need to type the roll number, and then as soon as you type the roll number and hit submit, it connects to the database and then fetches the result for you, pass or fail, whatever, right? Now this whole thing is a two-tier application design with a front end and a back end, right? Let's think about an application that is being used at scale. Let's say gaming applications. Database is one, but then connectors are many. People connect from all around the world. And that means that this database will be very busy. When I say busy, busy is the term busy is simply in English, but here in IT we use IOPS, input output per second. How many transactions it can take per second is IOPS. Oh, low battery. Okay, I'll just close it, yeah, because we have all of this.